Hello everyone, I am back. And if you made it through my previous video of how to assemble this thing, then you're ready for this step to go on and actually use it. All right, a couple of things I wanted to cover. Let's see, first thing, what do we have? Over here, when I routed this wire to the I think this is the X-axis stop, I don't remember. I went straight from the outside and into that connector that you could just see in there. I watched another video and they went underneath through, there's a hole here and then in here. It's a little harder to do because you've got to get the cable to bend and to go inside there, but it's neater when you're done. What else was there? Oh yeah, there is a clip right here, not a clip, but actually an opening that you can put the wire through, and that keeps this off to the side. I have seen a video where someone printed their part and this cable ended up getting inside of their part. And so they had to cut a slot in their part to get the cable out. So obviously you wouldn't want to do that. What else was there? There was a couple of other things that worked okay. Oh, when I put this together, I put everything together snugly and went back and tightened everything. Luckily, this one part, I did not do that way. I found out that the screws that hold that onto the slider, onto the rail, you cannot get to them after you've assembled everything. After you put it on this upright, it's this assembly right here. And after you put it on the upright, the screws are right there and right there. You would need to get to them from the other side. And if I get around there, you will see that you cannot get to them. There's those two holes that you had to go through, and you can see that this upright is exactly in the way to do that. So make sure you tighten those fully the first time. Speaking of which, what I did was I went through the instruction sheet after I had assembled this and went to every step and looked at what piece of hardware went into it and made sure that each one was tight. Okay, because initially I didn't tighten them 100% and then I went back and tightened them, but this time was to make sure that I didn't miss any in that whole process. All right. I ended up with the spare parts. They had a couple of spare screws. This is that extra Bowden tube piece. There's my extra nozzle in case I need it. And then there's that clip. There's the spare tools. I haven't used the cable ties yet. There are cable guides that you can print, 3D print. I think I would rather do that than using the cable ties. Neither here nor there. Let's see. Oh, here's a piece that I didn't talk about. What this is, ouch, it sticks you. It is the piece to clear out your nozzle. This nozzle has a 0.4 of a millimeter hole in it, and it probably will get clogged at some point. When it does, you lift this up, and then you use this to poke through the nozzle backwards and clear it out. So just warning you that I've had extreme issues with nozzle clogging on my Modix large format printer. So I suspect at some point I might have that issue in the future, and you might as well. Let's see what else was there. I think that was everything. Okay, I'm just looking over it to make sure there's nothing I forgot, which I don't think there is. So we can power it back on. Oh, I did forget to plug in the Z limit switch. And so what happened when I tried to hit home, it homed in the X and the Y, and then if it doesn't see the correct signal from here, it actually goes up a little bit, just, like a millimeter or two. So every time I tried to move it in the Z direction, it would just go up a millimeter or two. So I looked around and realized that this cable comes out from underneath the table here, and it goes right to there and plugged it in. As soon as I plugged it in, it worked like it was supposed to. All right, that's got everything. So now let's turn the thing on. Power switch. and it comes on. There we go. All right, let me go over here. The other thing I mentioned, but I didn't show you, is the voltage. If you look in here, I can't really see in there. Anyway, it says either 230 or 115. Obviously for the US, I wanted 115. So it says it clearly. If you had enough light, it's hard to see. Yeah, 115. I just plain don't have enough light. But if I did, you could see it. All right. So now the thing is on. The next thing is the little card, SD card that comes with it. It's a mini SD card. They do give you filament. I'm not going to use it because it's not enough to print what I'm going to print. I'm going ahead and jump ahead and print a big thing. I suggest you not do that. I suggest you print one of the pieces that's already on the card. Okay, so like I showed before, the card, this cap can come off, and it has a more normal USB, and you could have the card in there. You can plug it into your computer or laptop. My laptop already has a mini SD card, so I could just plug this straight in my laptop. The reason you would plug this in your laptop is any program that you have, you need to get it into the system here by using a slicer. I'm going to go over that in a future video, and you don't need to do it to get your first printout. Okay, the thing that's unusual is this actually goes in upside down. So if I push this back, you can see the two slots there. This has a USB-C. I haven't used it, and I haven't heard anyone talk about using it, but I would think that would work if you had a USB-C cable or an adapter for that piece. I may test that in the future. The unusual thing is that the card does not go in right side up. It goes in what I would consider to be upside down, but it's really easy to put in, stick it in there, and then just push it till it clicks and stays. Okay, so now that we've done that, the other thing I forgot, leveling the table. All right, so before you do anything, you have to level the table. So what we'll do is we'll come here, press on the button. Oh, and this is a plastic protective sheet. If it'll come off, doesn't matter. You can leave it on or take it off. Sometimes you'll see wrinkles in it. I'm gonna leave it on because it's too hard to take off with one hand, but in the future I'll take it off. All right, so there's my info screen. First I wanna go down to motion. So you turn this clockwise to go down, counterclockwise to go up. I go to motion, and I want to auto home. I tried this the last time, like I said, it auto homed in the X and the Y, but not the Z. That reminds me of a thing. The adjustment on these wheels, on the tension, each of these, again, this one's on an eccentric. The one underneath here is on an eccentric, and this one right here is on an eccentric. What I do when I get this together is I adjust it as tight as it will go, where I can still turn this wheel. It's not easy to turn this wheel, but this wheel does turn. There's no play in this, and there's no reason to make it any tighter than not having any play. Okay, and when you try to test for rotating, make sure you test the ones that are on the cylindrical one. For some reason, each time the one that's actually the adjuster was harder to turn. So these, I adjusted each of them so that I could just turn them with my fingers. So that means that you're down to zero play, but you don't have any excessive tension on them. The other thing I noticed is on mine, I can slide these back and forth on this one, and of course the table slides back and forth as well. But the Z, I can't slide it. I actually tried to pull it up. It will not pull. It will go down, but it won't go up. It has to do with, of course, the threaded rod. As I rotate the rod, it goes up and down, but it does not. If I hadn't already adjusted the tension on that and didn't use the can I turn this wheel method, what I would do is I would go in and take the set screw out here, or loosen this right here, take the shaft out, move this out of the way, and then make sure it slides easily up and down. But because I use the can I turn this wheel method, I don't need to worry about that. I know it's fine. What you have to watch out for is that the Z motor is lined up correctly and it's not going into a bind either all the way to the top or the bottom. Same thing here. If these were not straight uprights, were not straight up and down, it would get tighter or looser as you go up and down, and it would cause binding. So I would check that before you get too far. I already checked it, and like I said, I checked my can I turn the wheel, and it works. Okay, so let's go here, push the button, motion, and I'm going to go down to auto home. So that you can home it in the X, the Y, or the Z direction individually, or if you do auto home, it automatically goes home in all directions. So there's checking to the right and left, there's checking forward and back. And again, it's seeing that limit switch. It's going down in the Z direction until it hits the limit switch. And then it moves over. Now what you're looking for in the Z direction when it's at home is that the nozzle is right at table height. Well, that's very difficult to check. So what you do instead is you get a piece of paper. They say notebook paper, printing paper, whatever will work. I actually use newspaper because it's a little thinner and it makes it a little easier to adjust. Now what you really should do is come in here, go to motion, on that, and then go down all the way to the bottom and disable steppers. Okay, that way you're not fighting with the stepper motors when you're moving this around manually. Okay, so what you want to do is you want to come in about an inch. There it is, all the way to the left. So I come in about an inch, I move this table forward about an inch, and then I didn't mention this previously, there are these huge screws or handles to the screws that allow you to adjust the table up and down. All right, so since this in the Z direction thinks 0 is at this point and there's no way on this one to change that, what you have to do is you have to adjust the table from this point. So it is, ideally you would want 0 clearance. 0 is hard to do. So instead, a piece of paper, I think is 1/1000th or 2 of an inch. So what you do is you slide this piece of paper under there in between the two pieces, and if the paper won't go, you need to turn this knob. If I'm looking at the top and I turn it counterclockwise, it's got a screw that's coming in there. This is the nut. If I turn the nut counterclockwise, so this is opposite the righty-tighty, lefty-loosey. Oh, actually, it's probably the same. All right, so if I turn it counterclockwise, it's going to screw in. This is spring-loaded. It's going to pull the table down just a little bit. So I turned it, and I've already adjusted it. All right, so now the paper slides easily. All right, so then what I do is I go in and say, okay, it's too loose now, because it could be any amount of clearance at this point. So then I turn this, again, I have to think backwards because I'm looking at it the wrong way. So if I want it to go up, I would turn it clockwise. All right, and I just turned it a little bit because I had turned it a little bit. Now the reason why I like to use the newspaper is because with regular paper, you do it by feel here, okay? With newspaper, you not only do it by feel, but if it wrinkles up when I push it, but it smoothly pulls when I pull it, that's the right tension, all right? So that corner is adjusted perfectly. Right, now go to another corner. I come over here, and since I already have it correct in the forward-backwards direction, all I have to do is check for, move it over there. Once again, I can do the same thing. This is hard to do one-handed because I already have it adjusted. All right, so again, it won't go in there. It would if I could grab both. I've done it before. I grab both the front and the back and it slides in, but without putting tension on this piece of paper, it won't do. So it's no big deal. Let's see, if I want it to go down, I turn it to the counterclockwise. And you can see on the paper where I tried to cram it in there just then and it did the paper. All right, so I can always over adjust it. There we go. I purposely over adjusted it and then tighten it up just a little bit. One of the things I think I'm going to 3D print is a little clip with the up and down arrow right here, and clip it onto these wheels so that I can always remember which way's up and which way's down. So this one's adjusted correctly. All right, see, it pushes it, but it pulls real easy. All right, next thing is go to another corner. It doesn't matter what order you do it in. Go all the way to the end, come in about an inch. Same way here, all the way in about an inch. And once again, do the same thing. Adjust it here, and then use the screw. You can get to it right here. You look right in between there, you can see it. There it is. There's the spring, and what you're doing is turning the nut to either shorten that screw, and the spring's always clench it up, or you turn it the other way to loosen it. All right, and then finally you come over here and adjust the last one. All right, so what I do, rather than worry about it, is I look at for the edge to line up. That's an inch off, same way with the back. Okay, do the same thing. Slide the piece of paper. Maybe use the finished edge, not the torn edge. All right, and again, I adjusted it already, so I know it's right. And then finally, you want to go to the middle and check it. Now, there's nothing you can do about the middle because there's only 4 corners to adjust it. So you hope that it's not significantly different in the middle. In my case, it wasn't. It was exactly the same, so it's lucky. If it's not, then you might have to compromise on one of these corners. If this was way too tight, I would adjust one of the others. Now, one of the things you probably want to do is you want to go ahead and adjust this down before you start this process. I did not do that, and you can see the first time it went across, the nozzle scraped the table. Not a big deal, but it's something that you probably wouldn't want to do or would rather not do. Okay, so now I have it all adjusted like it's supposed to be. I have the little SD card in there. Now in my case, I actually put something I want to print. I would suggest you not do that because 1, this thing's going to take 30 hours to print, and 2, if it screws up, then I've lost that much more time. So you would be better off to start with something that's already on the card. So if I come here and I go to print from media, click on that. And what you can do is there is a user manual on here. There's a software drive. If you see the 01, 02, and 03 there and the little square there, that indicates a folder. So those are folders that have files underneath them. All right, so the user manual, I go there, and there's the assembly. They have an assembly manual. Click on it. Well, of course, this thing can't read and display the assembly manual. It's actually, I think it's a PDF maybe. Okay, but it does let you know there's a file there. All right, I go back to main. Same thing with all of these others, is if there's a folder, so then I go back up to here, print for media. Well, now what do I do? It's not what I want to do. I'm gonna print for media. Maybe that goes up a folder level. There we go. All right, there's your software and drive. There's an operation video. It is not an operation video, it is an assembly video. If you went through my assembly video, it took me almost 2 hours doing the video to assemble it. This one is less than 7 minutes long. Obviously, it leaves out some stuff by doing that. So it's up to you whether you want all the detail that I give on all these adjustments. It doesn't tell you anything about adjusting anything. It just says go ahead and assemble it. All right. All right. There's a box. The box has a lid and it's a heart-shaped box. with a lid on the body, so that's why it's in a folder. There's 2 parts to it. This is my folder. I have Jack's G code that I put in here. I put this SD card in my laptop. It has a slot, so I loaded my code. Again, my code's going to take 30 hours to print, but that's what I want to print. All right, so let's go down here, print from media, go down to where my part is. Oh, here's the rest of them. Okay. So many other things. There's my G code. There's Quake. That's the big hammer that you make in Quake. It's in 3 pieces, I believe. One of those recorders that if you print and give to your kid, he or she will drive you crazy. I suggest you not do that, but it's up to you. There's the owl that you can print. And then these are ones that are directly there. So there's a cat, a dog, and a pig. You can print those directly from right here. If I just print them, that would load them. All right, so let's go to, like I said, my folder. There we go. So I'm actually printing a chassis to a car, a C8 Corvette it happens to be, and I took the body off. All right, so that's what I'm going to print, but before I print that, I need to put some filament in here. So if I go over here, media. All right, so I'm going to go to temperature. Nozzles at 0. I'm going to preheat the PLA. Preheat PLA. All right, so now it's going off and it's set at 200 degrees for the PLA temperature and 60 degrees for the bed temperature. Okay, so you can see that it's slowly rising, and then 60 degrees. That's not changing, so I'm going to go in here and temperature, bed temperature. Let's go to bed. All right, I don't want to change that. I want to go preheat PLA. Let's see if it has a preheat bed. It does not. All right, so I guess I'm just going to have to wait. It doesn't take very long to heat it up as compared to the actual nozzle. Whenever I want to see what's actually going on, I come over here to the info screen, and there I can see that it's up to 144. Oh, the bed is heating up. 42, 43. It just was taking a while. All right. Tells me where my X, Y, and Z are. Of course, they're at 0. It thinks they're at 0. They're not. You can see that I left it in the middle. So at some point, I need to go home. Ideally, on the file that you have, the G code that you have, the first step it will have is to go home. I'm not positive I put that on this one. So before I do this, just to be safe, go to motion, and then auto home. Okay. Sometimes when you work with this, it won't do the auto home because it's not hot. It thinks you're trying to actually start to print, and it says, well, you can't print unless the filament is up to the correct temperature, and so I'm not going to print for you. Something I did not do, I did not open up the PLA. Like I said, I'm not going to use the short piece that they give you. I know I'm going to need the longer piece. So let me go ahead and set up my tripod. Hopefully I can do this without screwing stuff up. There it goes. I have to be careful this tripod does not solidly hold my camera in place, and I do not want to drop my... Alright, so I'm going to go ahead and put this up so that you can see decently what I'm doing. This tripod just barely fits here. Alright, I'm going to move this over, and hopefully I don't bump this and mess everything up. I'm going to go ahead and slide it down just a little more. And now I'll get my roll of PLA. Something to watch out for with your filament is don't buy too much, don't open too much. It actually absorbs water from the air, and if it gets too much water, it will not work correctly. On the Modix printer, the guy before me wanted to print with a bunch of different colors to see, so he opened up a bunch of rolls, and that may be part of my problem, is the rolls have absorbed water because they've been out for 6 months to a year, which obviously is too long. You can get dehydrators that will help with that, or they say you can actually put it in the oven and heat it up. I went ahead and got a 1 kilogram roll, which is kind of big for most people, but I already have like 10 things to print, and most of them are 30-hour prints. Some of them are even, one of them 60 hours. All right. One of the things you want to make sure is that your filament does not overlap. So when it tries to unspool, you definitely don't want it to have an issue with unspooling. All right, and this has tape on here. I'm gonna have to get some scissors. They do give you the cutters. I don't think I showed those. They give you cutters to use. They're really good, they're sharp. So I'll go ahead and use those. They cut this tape. So they taped the filament so it wouldn't unravel and cause issues. So all I'm doing is cutting this out of the way. And I wouldn't worry about it except for when it comes around to here. I don't want the filament getting caught on the excess tape. So I cut it off here, and so now it's free. This won't go through, the tape won't go through, and I don't want to mess with it. So I'm just going to cut off that piece. All right, so the next thing is the filament has to be routed. I'm keeping my finger on here so it doesn't unravel on me too much. All right, it goes on like this, and it just sits on this. Okay, and then here's the end of my filament. It comes down here, and if you come to this side, there is a lever right here. We've been looking how long, and a spring. All right, so this goes in through here. If I can see it, there's a hole right beside the shaft. Okay, so this comes in, and there's a roller that this moves and allows this to come in. All right, and then once you open it, you have to get that to go in here, and sometimes it's a little difficult to do. You have to turn it different directions until the two line up, and you can see my filament decided it wanted to unroll. All right, I'm having an issue that it does not want to line up. So I am rotating this. It has a natural curve to it. So I rotate it until it finally comes in. All right, now it goes through this. Now it's having the same issue right here. It's getting caught. So again, I rotate it as I go in and out. There it goes. And you can see this is translucent. So because I have a dark colored or relatively dark colored cover, I can see right there it goes to there, to the head. Now I have to come back up here and ensure that all of this is wrapped correctly. You don't want any tension on this. I will watch it closely. At first, again, my Modix, that was one of the issues. It had tension on this, and it stopped extruding, and I didn't know if it was the tension or something else. So again, I spent quite a bit of time messing with that. There we go. All right. Now, what I can do is I can come over here to the motion, push on this with motion, move the Z axis. I'm going to disable steppers and see if I can move this up. Again, because of that, I have to rotate the shaft while I'm doing it. The only reason I'm doing this, and I can also turn it down here, is so that I can see what happens here. What I'm going to do is I'm going to manually force this through here. If it's hot, see the nozzle's not hot because I screwed around so long and it said, well, if you're not gonna print, then I'm gonna shut everything off, which it did. So go back here to temperature, go to nozzle, no, go to, let's see, info screen. I'm not completely familiar with this. I'm familiar with the Modix because I've been messing with it for a month. It's not, let's see, temperature. Ah, there we go, preheat PLA. And preheat PLA. Oh, preheat PLA bed. Let's do that. And let's go back, go to temperature, and preheat PLA. Preheat PLA. So now you look up here, it's 260. So again, I have to wait for it to increase. My fault. All right, so in the meantime, I'm going to move the Z axis up. And what I want to do is I want to get it to where the PLA is at the end and it's actually extruding. And I can either do that by setting it, or I can manually do it. I want to manually do it. So it's up to 115, 121. So I've got nothing better to do while I'm waiting. Also, it shows me the fan's at 100%. The fan comes in here and it cools off the PLA because otherwise you can get too much heat gain and it will start melting the PLA ahead of time, which you don't want to do because then it can't force it through. Now this particular design is one of the less expensive designs, which is why this thing was only $99. And it has what's called this Bowden tube. And so what it is, the extruder's way over here. So it goes in here, this gear grabs a hold of the filament and forces it in, and it has to force it through this tube. Well, especially if you use soft, they have flexible filament. Obviously flexible filament would be hard to push through that tube, but even this, if there's any kind of obstruction whatsoever, it can get stuck where it can't push it through that tube. They have direct extruders that actually mount on top of here, and there is no Bowden tube, or in the case of the Modix, it's like this long of a Bowden tube. I suspect that might be part of the problem. Others claim it isn't, I don't know. But I have changed it and it did help with the extrusion issue. All right, so now we can see it's set for 200. It's bouncing between 200 and 201, 199, and then the bed temperature is set for 60. And sure enough, if I touch it, I can see that it's at 60. Okay, so now what I'm going to do is I'm going to use this little lever here. I'm going to move it forward and I'm going to push this filament. If it's heated up and everything's okay, I should be able to manually push this through. And sure enough, hard to see, but there's a very thin piece of filament coming out. Be careful and don't touch the end of that. It is very, very hot. That 200 degrees is centigrade, not Fahrenheit. Okay, so let me go ahead and push this off. Now here's the thing is, this is 1.75 millimeters. After it comes through the nozzle, it is literally 0.4 of a millimeter. It extrudes it down to that thin. The advantage of that is you get a really nice print. The disadvantage is it takes a while to do. Okay, I've got everything heated up. I go here, go to motion. I don't know that I have to auto home, but I'm going to just to be safe. So it comes over here, touches this switch, it says, oh, there I am. Goes over here, touches this switch. It says, oh, I know where I'm at. And then it lowers it. Takes a little while to lower it in the Z direction. If you watch it, what it does, it comes in, it hits the switch disengages or engages, whichever, whether it's normally open or normally closed. Then it backs off a little bit and comes and hits it again. it goes. All right, so now what I'm going to do, it's at home. I'm going to come here to print from media. I'm going to go all the way down to where I go to Jack's. Where do we go? Jack's G code. And there's my CE3E3, which is what the slicer puts in front of every file. C8 chassis. I have really long names so I can keep things straight. I'm going to push on that. It says, do you want to start the print? Cancels the default, so you have to make sure you turn the knob to print, and I push on print. All right, it's at 200. It's set for 205, so the print temperature from the slicer was 205. The preheat on the ender built in was 200, so I have to wait for it to heat up a little bit. And the extruder is heating, is what it says. There's my message right there. This is a progress meter right here. So right now it shows no progress because it hasn't started printing yet. You can see it's going off. So you can see it went home again. So that means there is a home routine on my printer, on my print file. Right? So there's a little bit of the excess. Oh, and by the way, this spatula comes with the printer. Hopefully I don't need it. So it's going in, and it just put down a thin layer right here, and that kind of makes sure everything's primed and ready to go. So it literally just put a long strip right here. Now it's going off and putting the outline of the part that I'm trying to print. So I'm watching, and again, the Monix printer I'm using, it's a big one. It's 2 feet deep, 4 foot wide, and it'll print 2 foot deep. I've got a 1 millimeter nozzle on it, so it's what, 2.5 times bigger than it. So when it puts it down, you can't miss it. This one, you have to look closely to see that it's actually putting down the filament. The first layer is the most critical. So I decided on this, I was just going to take all the defaults out of the software. There are over 200 settings that you can set on the slicer. You can customize it to do whatever you want, but I think a lot of the problems I was having with the Monix is it's not a mainstream printer, so I had to get the defaults from somewhere else. I got the defaults and I've had nothing but trouble. I've gotten 2 good prints out of it in the last month and a half, 2 months, out of multiple tries. All right, the first layer is the hardest one to get down correctly. So I've done nothing to this table, to that surface. I just left it alone. I tried not to touch it excessively when I was assembling it. What you could or would do would be to put down isopropyl alcohol to clean it. They also have glues that you can use. And believe it or not, one of those that works well is the Elmer's glue in the stick. You just go in and you can cover the whole surface. Also, hairspray is supposed to work. I have not tried it. I have a bunch of hairspray from other projects I've done. Hairspray works really good as a glue, believe it or not. So what it's doing now is, I told it to put a brim on there. And a brim is just a wide area. If you just had the 1.4 millimeter piece on there for it to stick down to the table, that's not much surface area. It would have a hard time sticking with something that thin. It's almost like a hair, a thick hair. So what it's doing, it says, well, if you want this thing to print and you want to make sure it sticks to the table, I'm going to put a band of filament down about so wide. And that way you've got something good to stick to. The risk is, one, obviously initially that it won't stick, but the other is as you start getting higher and higher, there's a thermal issue with the filament, that it's hot, expands and contracts with hot and cold. All right, so if you got, let's say, several layers up and it cooled down, it would shrink. Well, when it shrinks, it tries to pull up the edges. This way you've got these edges that don't have something, it's sticking past the part. So even if the part tries to pull up a little bit, you still have a little bit there that's holding it to the table. Obviously it would be a tragedy if it did shrink, it pulled up from the table, and then your part's sliding around while this is trying to accurately put down filament. All right, we're going to watch this for a little bit. Like I said, the first couple layers are critical to make sure it works, and then after that, you're probably pretty safe for that. So we're going to watch it, go ahead and print a couple layers, and then I'll go to, what is it, stop motion or whatever it is, where it takes a picture every minute or so, and we can watch it as it prints. Now I see some areas there from where I'm sitting, it has a different gloss, and so it looks like it could be pulling up from the surface. But luckily, when it goes back and I can see it and I come over this side, I don't see that gloss, and that's where it changes direction here. So far, everything's going very well. Cross my fingers. Let's see. Now, if you look at this, it says it's going to take 1 day, 19 hours, and 14 minutes to print, which is pretty much the slicer said the same thing. Or it might have said longer. I don't honestly remember, but. And the other thing is, these are just estimates on how long it's going to take to print. They're not absolutes. So I guess I could time this and see how long it's going to take. But of course, the only thing I have for a clock is in my phone, and my phone is recording as we speak. All right, so I'm watching the temperatures exactly at 2:05 right now. Bed temperatures at 60. There's my X, Y, and Z coordinates, which are obviously changing constantly. Z staying at 0.2, but the X and the Y are changing constantly. And then there's my, I don't know what that 100% is for. I could look that up. All right, so I can do this without messing things up. All right, it is now 3:19 my time, so we'll see how accurate this was when it gets done. Make sure you can see. Yep, you can see. All right, so let me see if I can find the car. Okay, so this is what I am printing, all right? Except that what I'm doing is I'm putting a different body on this car. Let me make sure you can see, yep, you can see it. Putting a different body on this car. So I removed the hood, the front fenders, this back fender right here. I'm leaving this part on the car because I don't want to have to remake that. But I took off this whole rear section, this fender, modifying this, flattening the door, and then the front is completely different. So I'm removing the front. I am keeping this bottom part right here from the factory. Don't remember what I was doing there. I'll have to look at it. I think I took all of this off as well. Same thing on the back, all right? If I open up this back hatch, all right, I'm leaving this back edge as a C8. Then the rest of it, I removed this. I did leave the third brake light. That can come or go depending on the design. Ideally, I'd like to go ahead and leave the factory third brake light if I can. Obviously, I removed the spoiler. And I'm leaving this bottom diffuser piece. So my body is going to come around and meet right here and use the same attachment points there. Ideally, I want to use the factory attachment points everywhere so that I can literally unscrew the factory body, put my body on, and screw it right back into the same holes, the same attachment points that it came from. Can't do that with the door. I literally had to cut open the door here to get rid of these two humps. These are just extraneous humps. There's literally nothing underneath here, so I got rid of that extra bulge right there. I think that's all. So what I did was I took all of those parts off, and then I have a 3D scanner, a high, medium end 3D scanner, and I scanned the entire body with all of the pieces that are underneath this panel. In other words, I can't see what's underneath this panel. Even if I open the hood, all it shows me, there we go, is the front or front trunk. That doesn't tell me anything. So I took all of this off, and I could see all of the structure that's under here. There's a bar that goes here that all of this bolts to. There's pieces under here. So I could see all of that. So when I design a body, now I know, all right, the factory fender's right here, but I know, let's say there's an inch, for example, all across here. So if I make a design, I can come down an inch. In some places, there's 2-3 inches of space where it attaches because there's a bracket underneath there. So I can look at it and say, well, if I get rid of that bracket and attach it to the piece instead of having that bracket, I could actually lower this fender, let's say 3 inches from where it is. So because I had multiple designs I'm going to put on the same chassis, it's critical that I know it fits. Now what I did was I had designers go off and design different bodies for me. And in some cases I looked at them, I offered the designers this file, and 2 of them said, well, I don't need it, I can do it without it. I was skeptical, but I went ahead and let them do it anyway. They came up with the designs were good looking, but sure enough, when I went on the computer and tried to put it on the body, it wouldn't fit. So now I know it's wrong, but now I need to figure out how do I fix it. What I'm going to do is print multiples of their bodies. And what it is there's parts of that chassis that interfere when I try to put the body down. It won't go all the way down because it hits something that's underneath those fenders. So when I print this out, I'll know everything that's underneath the fenders, and then I can take their body, I'll section it, and I'll say, okay, their front, maybe their front's okay. The front will go on just fine, or it needs a little more or less room, or maybe there's something on the C8 chassis that I can remove, like I said, one of those brackets or something like that. So let's say I'll take the front half, I'll put it on there where it can go. And then I'll do the same thing with the back. I'll take that back half, come from the back, slide it forward, and see where it can go. And then there's going to be space in between where it won't fit. I'll either have to raise it or actually have to fill in area. So what I'll do is I'll get some material, fill in the area, and I will make that body fit by adding material or moving things where it needs to be. Once I do that, I will, again, 3D scan the model, and then I will have their basic body style with whichever changes need to be made, and I can make a 3D print from that. It's a rather involved process, but it allows me to do everything at small scale, a lot less expensive than to do it at full scale. One of the other things that I noticed is on the C8, there are 2 radiators. The engine's in the back, so the radiators, there's 2 radiators in the front, and then there's also radiators on the sides here, right? And it's back under here, so it's about right there, all right? You can't see where that radiator is from the outside because of this. This is a metal model, so I didn't want to take my grinder and be cutting on this metal model. I may do that eventually, but actually it's gonna be easier if I just print one of these and open it up. But anyway, ideally, I'd like to cut this off. So where I see exactly where the radiator is, so I know where this fender needs to be. I want this fender to come in here and not extend all the way here and have this part. Well, I don't know where that line needs to be until I can see the radiator. On one of the models, I'm almost positive that if I do it the way the designer did it, that radiator will be visible from the outside. Obviously, I don't want people walking up and seeing this radiator sticking out the side. So I need to see how much do I need to move this fender forward so it covers up that radiator but still fits in with the design of the car. So these are a bunch of little things that, like I said, their designs are close, they're pretty good looking, they're just not quite there. And if you go to my one of my other videos, you'll see what's going on. Okay, to get this to fit, it won't fit this way. If you look, it's just a little bit too long, all right? Then I tried putting it this way. Well, it still won't quite fit. It misses it by a little bit, but it does miss it. So what I had to do was I had to have it print at an angle like this. Well, I'll flip it over, but it's going to print at the opposite of this, but it's going to print an angle like that. Now you can see, yep, sure enough, that fits because this is 220 millimeters, these two directions. It's 250 millimeters up and down. And this is, I think it was 278 or something like that. But by moving it around, I had to go in this slicer and move it a whole bunch of times to get it to where it would just fit in there. And so that's what we got now. So what you see is it's printing this tail section right here. That's what you see right here. Well, when I do that, the model's sitting at an angle. When it gets up here, this is too much weight for this to hold, and the whole thing would fall down. Even that brim that it put down there to try to hold it, that's not enough. This part over here that we saw it print at first, that's what's called support. It is literally putting plastic all the way up here, only so that when it finally gets up to this top part, this won't be trying to print into thin air. It'll be printing onto these support pieces. It wastes a lot of material. I think it was 45% of the material, something like that, that it's putting down there is literally just support material. I could have made this smaller and printed it flat this way. It would have used a lot less material, but in this case, I already had this model at 1/18 scale, so I wanted to make everything at 1/18 scale. If I didn't have this model, or this model was a smaller size, I would make it to where it prints flat so I don't waste so much material. Right. I do have another chassis that I'm printing, and it is flat, but even it, because this center section where the roof is, right, obviously there has to be room for the people to be inside of here. So in order to print this roof, it has to print support material so it's not trying to print into thin air right here. So what it's doing is it has to print support material in there. What it does, it prints it pretty sparse. It's up to you. You can set the infill. Again, I'm leaving everything at the default, so I'm not adding anything to it. In those 200 settings, any one of which I could screw up. So I'm going to go ahead and leave it alone and let it print. But even in it, I think the lowest I got was 37% support material. So that means 37% of the filament that it puts down is only support material. You have to cut out that support material afterwards, which can be a pain. Again, there are custom settings to make it as easy to cut out as possible. But again, I'm not trying to do everything straight out of the box and see what happens. Then after I get several successful prints, I'll start messing with the settings. As I've had issues, people have told me what to do, and they pretty much all say, oh, your bed's not level. That has to be the problem. Well, I've leveled my bed on the other one more times than I can count. They said the amount that you're extruding is not right. There's all these things. They're guessing, okay? I can tell. The other thing is almost everything they are guessing at, I've already tried, and it didn't help. It didn't make a change. So I just got frustrated. So I said, you know what? I'm going to go find a printer, a name brand printer, where there's already files out there, there's already settings out there, and I'm going to start with those default settings and then see what happens. And then, if I can change it, I will. There's several sites out there. One guy, can't remember his site, I'll have to look it up and tell you. I can put it in the link. But what he does is he tells you how you can print. In one case, he saved 80% of the time printing by tuning. All right, so that would be significant. In this case, it's going to take, what, a day? What are we down to now? A day and 11 hours. So I don't know what it was, almost 12 hours, 11 hours, 59 minutes. All right, so if I could cut that down by, 80%, that would make a huge difference. But even if I got 30% knocked down, that would make a big difference. But again, initially, I'm going to leave it alone My goal is just to get successful print. All right, I think I've talked enough. I think we've seen enough. It has a flat first layer down on everything, I believe. Let me look and see. All right. So it's showing after the 1 day at the time of the 1 day, however many hours, it shows a percentage. And it also shows, oh, a counter. So it says it's been printing for 19 minutes and it's 88% left. I wasn't sure what that meant initially, but now that I see it's 88% left. And we are at 1 day, 13 minutes and 25, no, 1 day, 13 hours and 20 minutes. Yeah, okay. All right, so what I'm trying to figure out is, are we done? Is all of the first layer done? My other robotics printer tells you what layer it's on as well. So that's what I was looking to. When it went to layer 2, I'd say, oh, we've successfully put down an entire first layer. This one doesn't have that as a reading, so I'm trying to figure out, am I completely done with the first layer? It's doing a good job so far, but I don't know how much it's going to fill. There's obviously going to be some spaces, some support material, and that. So I'm going to watch a little bit longer. Trying to see if, all right, so what I'm looking at is the Z is still at 0.2. Oh, so that's something else. I found out as a general rule, you want the layer height to be half of what your nozzle diameter is. So in this case, it's 4/10 of an inch, the hole there, which again is that piece right there. All right, so half of that is 2/10. So the Z layer height is 2/10 of a millimeter. It is still at 0.2. So that means we are still on the first layer. All right, I'll know that we're on the second layer when that changes to 0.4. Okay. The other thing, remember I told you about support. You don't need or want the support to be solid. Okay, so if you look here, it did a crosshatch pattern. It just printed stuff like this, and it can span a little bit of distance without material in it. It just can't go a long distance. So the software, the slicer software says, okay, based on the settings for this specific printer and 4/10 millimeter and everything, and PLA, you can span this much of a bridge without support material underneath. So it calculated what this hatch pattern should be so that it can print. All right, it just now stepped to 0.4 on the Z-axis, this last one. All right, a couple other things. I'm still at the 205, which I should be somewhere in that plus or minus a degree or so. I'm still at 60 degrees for the surface temperature. The fan now is running 33% of the time. Okay, again, it's trying to control the temperature of the filament. That extruder gets real hot, 205. If it lets it get too hot, it'll start heating the PLA out inside the tube and inside the heater as it leads there. So it's saying, all right, I need to run the fan 1/3 of the time to keep that from happening. All right, so again, the X, Y are running around wherever they are. The Z is now at 0.4, so I know I'm on the second layer. We are down to 92%. All right. And you know what? That says 0.92%. So that means I am still less than 1%. It's not counting down, it's counting up. So that's 0.93% now. All right, and we're down to 1 day and 18 hours and 15 minutes. Obviously, you don't want to watch it for that long. I don't either. The main reason I got this is, one of the main reasons is the big printer that I'm working with, is an hour's drive from here and then an hour back. And then we've seen it's going to take 30 hours to print something. Obviously something like this would take way less time on it because it's printing a whole lot more. It's printing down 1 millimeter at a time. So it takes less time, but I'm also in each case printing something bigger. So let me show you what was previously printed. I didn't print this. The previous guy that was messing with the printer or trying to get it to work printed this. You can see that this is significantly larger than what I'm trying to print now. So eventually, after I get all this working, I want to print something even larger than this. So again, it's 4 feet long, so I want one of these that's 4 feet long, 2 feet wide, and 2 feet tall. That's not those dimensions exactly, but that's the box that I can print in. And that ends up being about 1/4 of the size. This is 1/18 of the size. The one I'm going to print when I get everything dialed in is going to be 1/4 of the size of a real car. So it's going to be a pretty big model. The other reason I'm waiting is I'm waiting on parts for the other printer. I've actually had them on order for a month and I'm still waiting for them. Again, one of the other disadvantages of having an off-brand printer is the sources for the parts are not as readily available. For those of you that aren't familiar with 3D printers, it is basically an erector set. If you look at it, if you saw me assemble it, it is nothing but extruded aluminum rails. These are pretty standard amongst all of them. And you put some screws and some little, drill some holes, tap some holes, use some of those T-nuts. The power supply that comes from this, you can buy this power supply. It's nothing to do with Creality and Ender. The display, that's probably their display. Sometimes the hot end is there, sometimes it's not. It's a third party. So you can actually build one of these from scratch. Problem then is you have to come up with the software that tells it how many steps to put to go a certain distance, how many steps to go up and down, and control the temperature, all of those things. So in a lot of cases, you're really paying for the software in addition to the hardware. But a lot of this hardware, you can literally just go, if one of these goes out, I can look at, see who the manufacturer is. There's probably a part number there, and I can order those parts directly from the manufacturer or from any of their distributors. With the Modics, it's a little more difficult. So I've been getting them from their suppliers. They're in Israel, if I'm not mistaken. So again, there's another problem. Same thing with their help. If you email them for help, they're on a different time zone than I am. So it typically takes an entire day, ask a question, get an answer, and then try to fix it. That's where user groups come in. You'll see Facebook groups and user groups for all of this. Again, that's another advantage to this. There's, I don't know, let's say there's 200 users in the Modics printer group. There's thousands of them on the Ender and the Creality. So if I ask a question and there's only 200 people that can give me an answer, probably because of what I'm trying to do, probably only 25% have experienced the issue I'm having. Of that, I'm waiting for one of them to come back with an answer that wants to answer. If I have 1,000 people there and I put a question out there, chances are within an hour, I'm going to get an answer back. All right, so I'm going to sign off for right now. So go ahead and like, subscribe, hit the alert if you want. Let's see, what's good. Oh, hit the thanks. That gives me a donation. And if you don't like what I'm doing, you don't know Jack. Bye.